Hello students, the topic for today's video is the propagation of uncertainties in chemistry as applied to the IBDP or the A level. Now, if you are absolutely new to the concept of uncertainty, please watch my previous video in which I have introduced the concept of uncertainties. Now coming back to the topic for today, that is the propagation of uncertainties. Let us first try to understand briefly what is the meaning of uncertainty. Uncertainty is a doubt about the true value, and that is because of the measuring instrument, which always has some error in its measurement. For example, when we say that length of some object that we have measured is 10.0 centimeter plus or minus 0.1 centimeter. That means this 0.1 centimeter represents the uncertainty in the measurement. That means the true length could be either zero point 0.1 centimeter less, that is 9.9 centimeter, or 0.1 centimeter more, that is 10.1 centimeter. Somewhere between this is the true value. So this is about uncertainty. But what do we mean by propagation of uncertainty? Now, suppose in any particular problem that you are doing in chemistry, there are these two measured values. One is 10.0 and it has an uncertainty of 0.1, and we have to add to it another value, that is 5.0, which itself has an uncertainty of 0.05. So what is the final answer? So that means what happens to these two uncertainty values in the final answer? That is what we are going to find out. In the same way, suppose there are two values, one is 10.0 plus or minus 0.1, and we have to multiply it by another value which is 5.00 plus or minus 0.05. Then what is the answer after multiplication? So what happens to these uncertainties? That's what we are going to study, and that's called the propagation of uncertainty. Now, at the IBDP chemistry level, we apply simplified methods of statistical analysis. If you refer to more advanced methods, they are going to differ from the methods suggested here. However, IBDP has recommended these simplified methods, so you need to know only about the simplified methods of applying the statistical analysis. So now, when we express uncertainties, there are three different ways of expressing uncertainty. That is absolute uncertainty, or percentage uncertainty, or relative uncertainty. For an example, if suppose we write 15.0 centimeter cube, which is a volume, and plus or minus 0.2 centimeter cube, then this 0.2 centimeter cube represents absolute uncertainty. That is, absolute uncertainty is the uncertainty in a particular measured value. Now, suppose we have to find out the percentage uncertainty with the same values, then we have to apply this formula. That is, the value that we measured was 15.0 centimeter cube and the uncertainty was 0.2 centimeter cube, multiplied by 100%, which is 1.3% to two significant figures. That gives us the percentage uncertainty. Now there is one more method, that is the relative uncertainty. It is similar to percentage uncertainty, except that multiplied by 100% we don't have to carry out. So simply 0.2 centimeter cube over 15.0 centimeter cube is the relative uncertainty. So 1.3% therefore changes to 0.013, again to two significant figures. Now here is a reminder that the values which are constants, like specific heat capacity of water, which is 4.18 joule per Kelvin per gram, they have no uncertainty associated with them because they have already been given and they are not the measured values. In the same way, the counted values, like if you count the number of students in a class and you get a number like 20, 21, etc., then these counted values also do not have any certainty associated with them. So when we are considering the propagation of uncertainties in calculations, we have to actually, there are two different methods. One is applicable for adding or subtracting, and the other is applicable for multiplication and division. So when quantities with uncertainties are added or subtracted, the absolute uncertainties are added. So even if you subtract two quantities, you have to add the absolute uncertainties. For an example, that suppose using a thermometer, you measured a change in temperature and the initial temperature in degrees Celsius was 23.42, having an uncertainty of plus or minus 0.02, and the maximum temperature that you recorded was 57.58, also had the same uncertainty. So what is the change in temperature? So obviously, if you don't consider uncertainty, then you simply subtract the two values and that gives you the change in temperature, which is 57.58 minus 23.42, which is 34.16 degrees Celsius. But because there is uncertainty in every measurement, there will be an uncertainty in the final answer. So as said earlier, that we have to add the absolute uncertainties. So you add the two absolute uncertainties. So it is 0.04 degrees. So the change of temperature will be recorded as 34.16 plus or minus 0.04 degrees Celsius. Now, you might be wondering that whether this is really true. So I have shown you a discussion on this, which is generally not given in most of the textbooks or in videos, is this, that suppose we measured the value of 57.58, but because of the error, it was actually 50. I've added this 0.02, so that means the real temperature was 57.60, or and then I have subtracted a value of 0.02 from 23.42, considering that this could also have been recorded. So now what I did is that I have subtracted the two values which I got by addition of 0.02 and the subtraction of 0.02 to consider the two limits, and therefore I got 34.20 as the difference of the temperatures considering the uncertainties. And we have measured 34.16 by simple subtraction, but if we added and considered that what could have been the maximum and the minimum temperatures recorded, we might have got the difference of temperature as 34.20. So if you subtract this 34.16 from this, you actually get 0.04. That means the uncertainty in our measurement in the difference of temperature can be plus or minus 0.04 degrees Celsius. I hope you understood the logic behind adding the absolute uncertainties to find the difference between the values. Okay, now we go to the multiplication and division. So when we multiply or divide quantities with uncertainties, we add the percentage uncertainties. We add the percentage, not the absolute uncertainties. So this point should be clear. So let us consider an example. What is the absolute uncertainty when 2.57 plus or minus 0.01 is multiplied by 3.456 plus or minus 0.01? 007. And how many significant figures should the answer be quoted? So let us first simply multiply the two numbers, that is 2.57 and 3.456 on multiplication. By using a calculator, you get this particular number. It has too many significant figures, but let it remain like this for the time being. Now let us calculate the percentage uncertainty associated with each one. So the percentage as the uncertainty associated with the first value is 0.01 over 2.57 into 100, which is 0.39%, and the percentage uncertainty associated with the second number is 0.007 over 3.456 into 100, which is 0.20%. So the sum of the percentage uncertainties is 0.39 plus 0.20, that is 0.59%. Okay, so now we have to find out, we have to convert this percentage uncertainty into absolute uncertainty. That means we have to find out the 0.59% of our value. That means this value. So this is the value without considering the uncertainties, and 0.59% is the uncertainty. So what is the 0.59% of this particular value? So we do that 0.59% upon 100 multiplied by this value, which gives us 0.05, and we have rounded it to one significant figure because the absolute uncertainty in IBDP is generally quoted to one significant figure only. So now we have got the absolute uncertainty in the second decimal place. So this answer should be written also to the two decimal places. That means it should be 8.88, because 8 is followed by 1, so 8 will not be rounded. So 8.88 to two decimal places. So the final answer should be 8.88 plus or minus 0.05. So these are the two simple methods that we have to apply, and I think you understood. One more thing, that when multiplying or dividing a quantity with an uncertainty by a pure number, the absolute uncertainty is multiplied or divided by the number so that the percentage uncertainty stays the same. Meaning is that if you have 12.12 plus or minus 0.01 and you have to multiply it by 3, then what should be the answer? You multiply 12.12 by 3, so you get 36.36. Also multiply plus 0.01 by 3, that means 0.03. So the answer should be 36.36 plus 0.03. Now the percentage uncertainty remains the same, that is 0.083%, whether you consider this value or this value. In the same way, if you have 2.00 plus or minus 0.03, where the percentage uncertainty is 1.5% and you divide it by 3, so 2 divided by 3 is 0.67, and then 0.03 is also divided by 3, so it is 0.01. By doing so, the answer is 0.67 plus or minus 0.01, so the percentage uncertainty remains the same. So this is what you have to understand. So in this preliminary introduction, I think you understood the basic ideas behind the propagation of uncertainties, how we carry out the method when the operation involves addition or subtraction, or when the operation involves a multiplication or a division. So until next time, when we'll continue more about the propagation of uncertainties. Bye for now, and if you liked the video and if you understood the contents, please like and comment. Thanks a lot.